Hey everybody, this is Larry. This is day 7 of the Leetcode Daily December Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, any questions and anything like that. This is Spiral Matrix 2. So if you're new to this channel, basically my format is that I go through my thought process as I see the problem for the first time. And I'm solving this live, including the explanation. I come up with the explanation live. So if that's a little bit too slow for you, feel free to fast forward or skip ahead. Yeah, because I think it's more important to kind of go through my thought process as I'm solving it and not just giving you the answer. Okay. With that being said, today's problem is Spiral Matrix 2, as we said. So basically, we have having a okay, so it's a square matrix, and you're trying to just go rotate. Okay. So I think there are a couple of ways to do this. Or a couple of strategy to attack this. One is maybe some kind of like formula that transform a cell into a number. There are a couple of ways to maybe just to go around that. For me, the way that I usually write these is that I will do it with simulation, right? And what do I mean by simulation? And what I mean by simulation is just fill in the cell one by one. And the reason why I can do that is because if you do that in a relatively not annoying way, you're going to look at each cell at least or at most once or one time for each of them. And as long as you do that, then that's going to be optimal, right? Because you have to return the entire matrix anyway. So you cannot do faster than looking at each cell at least once. There might be harder versions where you're giving a cell number and you have to return the answer, but that's going to be a problem that you can upsolve maybe in another time. But for me, this is going to be a simulation problem, and I'm going to try, especially during a contest or something like that, because during a contest, I think for me that's the way that's less likely or least likely to be error prone. Because and if there are different rows, you can change your code quickly to accommodate different rows and so forth. Maybe, depending on how similar they are, right? And if you're in an interview, or if I was in an interview, I might go through the different strategies that we can do, and then maybe kind of try to see if I could get a nudge on which direction to go, just in case someone really, the interviewer really likes a particular solution, because they're the same. They have the same worst case complexity, so it shouldn't really matter. Okay, cool. So with that being said, it becomes an implementation problem. As I said, you just kind of walk the matrix and look at each cell a constant number of time. So okay, cool. Huh? Did I already? Have I already done something similar? Maybe I already done this problem before recently, but I actually don't remember this, to be honest, because all these kind of look similar anyway. But okay. So now yeah, so now let's start by creating a grid, and here I used 0 because 0 is not one of the inputs, so it becomes like a flag almost, so that like you could just use it to determine whether you've used it or not. Let's see, and then now we can do, let's start a counter is equal to 1 maybe, while counter is less than n times n. Okay, we have to, let's also get the current position, and let's get directions, right? So we want to go right, down, left, up. So the right, if we're going right, it'll have can type positive y direction, going down is positive x direction, going left is negative y direction, and going up is negative x, right? So those are my directions, and then maybe current direction, something like that, just to be sure. Okay, so then now we can update grid of xy is equal to 0. Oh, sorry, is equal to counter, increment counter, and then try to figure out the next direction. So yeah, okay. So yeah, okay. So the next is you go to x plus t, dx dy, y plus dy, dx dy is equal to directions of current direction. Okay, so if this new next number is greater than 0, or if it's out of bounds. So if I usually write it this way, I don't know if this is the cleanest way, to be honest, but so if this, so if not this, or not or you use 0, then we do current direction is equal to current direction plus 1 or mod 4. So that's pretty much it, I think. Maybe I'm off by 1 somewhere, but that's one of the cases. Real quick. Whoops. Huh. Oh, yeah, of course. I forget to actually set x is equal x, y is equal to nx, ny. We actually have to move it along, of course. Oh, no. Oh, wait. So basically, what we only changed the direction once, right? So that's why we have an if statement like this, because you don't. There's never going to be a case where you have to change direction multiple times. But yeah, I am a little bit silly here, my carelessness. A little bit copy and paste, but yeah, this is why we test, and also this is why, you know, I find these problems kind of annoying, but because it's just very error prone. And this will help me visualize. Is this a good answer? Okay, looks okay. Okay, so it looks okay. So let's give it some, because n could be up to 20 anyway. So I think if this looks like it's run fast enough, then it should be okay. Unless it gives, I was just double checking whether like 0 is a valid answer. I don't know if my code is correct for that. But in any case, this is accepted. So what's the complexity? Well, again, we look at we're going to run each cell at most over 1 times because we do some other bounds checking, but over 1 work. So given that they're n by n cells, this is going to be O of n squared, which is linear in terms of the size of the grid that you return. The actual complexity is a little bit nuanced, because the complexity is usually based on the input size, and in this case, the input it's a number, so the input size is always going to be the number of bits, and so you can say that it is technically exponential or something like that. But let's just use n squared to keep it simple. And then space is the same thing, because we have to return at least n squared into the grid, so that's going to be O of n squared. That's all I have for this problem. Let me know what you think. The implementation is a little tricky, but you know, with experience and practice, and a lot of practice, you know, you can think about the problem a little bit better. And for me, for this problem, it's about the invariant, about, well, changing the direction at most once, and also just making sure that we only execute n squared times. That's all I have. Let me know what you think, and I will see y'all tomorrow. Bye bye.